Hey guys, welcome back to another coding challenge. Today we are going to solve another linked list related coding challenge. And for this one, we want to check to see whether a linked list is a palindrome or not. So imagine something like this. So our linked list currently only includes numbers. So why not use numbers here as well? So let's say our linked list looks something like this, right? So a palindrome is a kind of almost we can say data structure that could be spelled the same forwards or backwards. So this one spells as 1 2 3 2 1, both in forwards and in backwards, right? So this is a palindrome. Okay, now we would want to know whether something is a palindrome. So palindromes have two types. One of them is the kind that has a center or a middle element, and the other one is the one that doesn't have that center or middle element. All right, so this is how it could be without a center element. All right, so we would want to detect both kinds of palindromes inside of a linked list with the best runtime possible. All right, so we can ask for the length of the linked list beforehand, but that would not make us become more creative and solve this problem specifically for linked lists. So we can so let's suppose that we don't have any links for this linked list, or any input linked list for that matter, and let's suppose that we are only given the first node of this linked list, right? So we are only given the first node of this linked list. All right, how can we detect whether this element over here is the same as this element, and this element is the same as this element, and to figure out whether we have a center element or not? So one way to do this is to reverse the linked list. So like imagine that we are folding this linked list and then comparing the first value with the second value, and with the last value, and doing the same thing for all the other respective elements, right? So this is one way to do it, but this requires us to traverse through the linked list at least once, to just reverse the linked list. All right. So I don't think there's any other best method to do this, and I think the best conceivable runtime would be at least 11 for this exercise. So how are we going to reverse a linked list? So basically for the linked list to be reversed, we need the node.next element to point to the node itself, right? So currently it's in reverse order. So currently the node is the current node is pointing to its next node, right? But we want to reverse it. So the dot next of the current node would point to the current node, right? So we can just grab this and put it inside a recursive function, and it would work with no problem at all. So the way it works is like this. So our function would look something like this. So let's call it maybe maybe recurverse for reverse, right? And it will get the linked list itself. So let's say it will get a node called n, and it will call itself over and over again, and it will return a node as well. Okay, so the first node or the head of the reverse linked list, and it will call itself, or it will try to return the goal here is to return a new node, right? That its data is grabbed from the next node, and it's pointing to the current node, right? And basically, if you watched the previous video, you know where we're going with this. But if you didn't watch it, so this is what's happening here. So we are saying that we have a function here, and this function is calling, wait a second, we want to get to a place where we have a function, and this function calls itself, and it calls itself over and over and over again until we hit a base case. And when we hit that base case, this function starts to resolve the base function, and it will help us resolve all the previous calls as well, so that we can return this this final result here. And the return type of all of these functions should be the same, or must be the same. So we want to return a node here, and what else? And we have to call this function inside itself, right? So we want the next node to point to the current node, and our base case would be if the n.next was null, right? If that ever happened, then grab the n.next, or just, yeah, here you would want the line that we have below. So maybe I'll relate these two lines together. Okay, so that's what you want to happen. And for all the other calls, so if we don't hit the base case, or wait a second, so our base case should be a little bit different in that if the next node is null, then it doesn't have a .data field attached to it. So we might need to look 2 nodes ahead. And if this one was null, right, then grab the data of the next node and point to the current node. Okay, so we will do this, and then we want to call the function over and over and over again. So we will say recurverse, and we will pass it the next node, right? We will pass it the n dot next. So we'll try to do this over and over and over again. So, and what will we do after? Like, what result will we get from this? We will get the next node. Alright, so after we get the next node, we want to point to n here, or store it somewhere first, or next, maybe, and then say that the final return of our function looks something like this. Return a new node that is pointing from next dot data to the current node in the parent function, right? In the previous recursive call. Okay, so something like that. And when we hit the base case, the way that we know it is that we look 2 nodes ahead, and if that is null, then we know that the next node is the final node that has a data. So we will read that data and then point to that, and then like one of the calls is resolved, and then we can move back up. So this would be our base case, and then we can move back up. All right, so that's that. Now, after doing this, we will have to still use this reverse linked list. So the return type of this, so imagine that we have another method, and we called recur verse there and passed it our input, and it returned something. Maybe I write these down in blue. Okay, so we have a recurverse, and we passed it our end node, and it returned something. Let's call that rev for reversed. And this is our reversed linked list, right? So this is its head, and we have a variable that is assigned to it. Okay, and now what we want to do is to create a while loop. So while, and we will say for now, like, it doesn't matter what the condition is. It does matter, but we will come back to it. But basically what we want to do inside this while loop is to check to see whether rev or the main input linked list's data matches with rev.data. So rev.data is the reverse linked list. So when we, like, the first node of the reverse linked list is actually the last node of the original linked list. So what we are essentially doing is that we are traversing in 2 opposite directions, and we are comparing values one by one, and we might want to return false at any point at the first mismatch that we see. So I'm going to wrap it instead in an if statement. So if n.data didn't match rev.data, right, then return early and return false. I know I'm not writing false correctly for Java syntax, but it's just pseudocode. So that's that. And if that happened, we want to do that, and then we want to go to the next node of the linked list and the next node of the reverse linked list, right? So this loop would run and run and run until we do that. But again, the runtime of this, something like this, would be to go through all n nodes of a linked list and get its reverse linked list, so O of n, and to go through every, and I should say that, otherwise we will return true if we don't return false. Okay, so that's that. And we then have to go through this while loop and like check all n elements again, and that would be another O of n. So I think we can do better, slightly better, and we can increase the performance of this by about half of n. So let's see how we can do that. So while we are calling the recurvers function, we can also pass it. Let me write this down in green. We can also pass it another variable, and we can call it, and we can call this other variable something like L for length. Okay, so we can actually calculate the length at the same time. And the L is defined over here, so it's of type, let's say, byte. And it's L, and it's initialized to 0, okay? So we have that, and we pass it to our recursive calls, and what we do here is that we receive it, basically. So I have to pass it down always. Okay, so do I have to receive it? Yeah, I have to receive it. Yeah, because the functions aren't nested. Okay, so what we are going to do with that is that we first receive the L's, and then what we do at the first, at the first call to the function, or at the first line of the function, we will increment the L. Okay, so when we reach the final call, and we will pass the updated number to the function itself again and again and again. And when we reach the final call, we have the value of L in our outer function, in our outer method, and we can use it to become more smart. So we can say while, and we can use L for our condition. So while so we can actually, we don't need to use a while loop anymore. We can use an if statement, but here we can improve our while loop as well. So we can define another byte. We can call it I and initialize it to 0, and we can say at the end of each iteration increase I. And we can say that while I is less than L divided by 2, right? So we will only want to check this set of conditions for half the length of the linked list. So that would give us O of n half, or O of half of n, okay? And that would make our total big O of runtime from O of 2n to go to big O of 3/2 of n. Even though in the final result, in the final estimation, we will drop the constants, but still it's an improvement for a little bit of increase to our space complexity. But this increase in our space complexity is constant, so I think that's worth the improvement in runtime, right? So for the runtime, it's actually linear, but for the space, the increase for the runtime, the decrease that we had in the amount of runtime is linear, but for the space, the increment that we made was constant. Okay, so for any size of linked list, we will only add these two variables. And if we use a for loop, we can scope this I to only this while loop. Right, so without further ado, let's go into the code and try to implement this algorithm. So here in our code, let's first define that linked list, right? So let me actually get these back and let me link these, right? And I'm gonna change it to something like this. So 4, 5, 6, okay. Or yeah, let's make it an actual palindrome. Yeah, that's good. So this is what we had in our example. And if we print it to the console, it should work as we expect it to work. And it does, which is fantastic. I'm going to remove this line as well, or have that and increase its length. Okay, so let's define our reversing recursive function here. So static, it returns a linked list node and it's called recurverse, right? And it receives a linked list node, and let's call it n here. And inside the body of this function, what we want to do is to have our base case as if n.next was null, then return with this linked list, return with n.next.data and n, right? Yeah, and otherwise we will call the function again and again. So I'm going to call it, do I have to call it anything? Yeah, let's call it something. Or next node to be, and let's call this node as well, just to stay consistent. Okay. Now var next node is a new linked list node that we don't have n anymore. Is pointing from that to node, right? Oops, no, we don't want to create that linked list here. So we call recurverse over and over and over again, and we pass it node.next. Okay. And here we'll say return new linked list node of next node.data, which points to node. And let's test this method and see if it works. So it's, let's call it on node 1, and let's store its results, and let's print out its results. What did we do? 1 1 2 3 2 1. Let's actually change it to something that is more apparent. 5 1 2 3 4 5. Okay, so for the last one, so I bet if I change this to something else like 0, yeah, that is actually the first node. So that is working fine, but these lines are not working fine, so we are not calling our recursive function correctly. So we will store a reference to the next node. And what is the data type of the second argument? It's a linked list node. Okay. So the base case is evaluated, and then we have the first value of this as, we actually console log the node at each iteration, node.data or node.data. 1 2 3 4 and 5. Okay. So we are going to the very, very last node. Oops, what am I doing? Five, 5 5 5. Why is next node always 5? From the first iteration till the last one is 5. So next node is not actually changing, right? Okay, so if we call it for the next node, oh, it's for when it resolves and it's moving back up. Huh. Do this. And it's not JavaScript, so let's watch our quotations. Sorry. So, okay, so 5. Why is this happening? So it calls itself, it goes to the next node, next node, next node, next node, until the next node of the next node is null, which would be this node over here, and which now this evaluates to 5. It has to evaluate that. And what is the current node? The current node should be 4, right? Should be 4. Do I have to call it with that? I don't think so, but let's see. Oh no, so let's look at our previous solution here. How do we use recursive functions? We're here. So this is our recursive sum function. We were doing this. We were calling our function with these, and at the base case, it was adding those two values, and after the result of the next node was resolved, we created a new node just like this. I'm not assigning anything to node. Now I'm creating new nodes, right? But I'm pointing to the previous node. So what happens if I do this? If I say var current node and set it to new linked list node with node.data, and here put current node, what would it now point to? Still pointing to 1. Now what happens if I do the same pattern here as well? Var current node, or if I'm doing it at both places, let's do it here, and let's instead point to current node. What will be the resulted linked list? Nothing. 1, 5 to 1. Why is that? that because the current node is overridden at each iteration? This should return us the next node, which is received here. And we want to do this with it. Grab the data of the next node and put it in the current node. So when the base case is resolved, so we have the 5 node. Now we want to get the current node. Why don't we have the current node there? After that is resolved, I expect it to get out of the final call and go to the previous call. And in the previous call, get the value of this, which was returned here. Put it here. Now we have another current node. And this node, which was... Okay, this node is this, right? Okay. So maybe I should add a dot next here. 2 to 1, no. Maybe, let me see. So this is... So we are basically updating the pointer of that node to the current node. We are overriding the pointers. We are overriding the pointer. So we are creating that final node, but after that we are only overriding its pointer. So we get that value, and then that would become my current node. That's right. But what will I point to? Its previous node. And so that should work, but then at the next call, the result of this has to be somehow... So node.next is stored there 5 to 4. Then what is happening here? And should I call it with... The current node is not changing. It's a node that's changing. So maybe I can just use the node value here. And then when we hit the last case, it gives us 5 pointing to 4. Then it resolves here as 5. Then we say 5 pointing to 3, 3, 3, 3. And then 5 pointing to 2, 5 pointing to 1. So this is not changing. So what if I do this? No. Interesting. Am I able to .4? If this is 5, then this dot next should be 4. Then 4 should point to 3. But why isn't that happening? Am I understanding this correctly? Gives me 2. So let's write down what we have there. So we are having this. We are saying that we have a linked list. Like this. 1, 2, 3, 4, 5. At first, what we are doing is that we are calling this function over and over and over again till we are calling this function over and over and over again. So so first for the f of the first node, so f of 1, f of 2, f of 3, f of 4, right? So for the f of 4, the next node of the next node of 4 is no. So it's the dot next, and so this is dot next of 4, and here we have another dot next of 4, right? So this is no, so we hit the base case, and it should evaluate to the next node, data, which is 5, pointing to the node which is inside the parentheses. So it should say 5, that is pointing to 4. So I would write it down as this. So this is 5 pointing to 4. And we are talking about this 4 over here, this address in memory, okay? Now, after that, we have a variable called next node, and next node is assigned to that node over there. To that node over there. So I'm going to say next node. Next node is the result of the next call. So we have this result stored somewhere, and then we are using that, the data of that, to point to the current node. So this now points to 3, which is here, and then in 2 it points to 2, and then in 1 it points to 1, right? So this makes sense. So we are not reversing the linked list yet. So what we want to happen is that 5 points to 4, 4 points to 3, 3 points to 2, 2 points to 1, right? So maybe I should say that we have a new linked list node and it doesn't point to anything at this point. And after it's resolved, then what we are doing is that we will point to it, but by using the data of the data of next node. Do we need the data of the next node here? Is that the next node? It would be our head, right? Head node, or previous node actually. And then it should previous node dot next should be node dot a new linked list node of node dot data, right? We will call it again and again and again, and what we want to return is just priv node. I hope it's correct. 5 pointing to 1 now. Priv node. So now we have that 5 there, which is not pointing to anything. Now, after it's resolved, we will have 5 stored here, and it points to 4. Then we have 4 stored here, and it should point to 3, and then 3 stored here should point to 2. 2 should point to 1. So why it's not working this time? So the base case is still 5. And we are still returning something. Okay, so we are returning priv node and assigning the next value for priv node. So maybe we want to return this thing over here. So maybe if I want to do that, then I may want to assign this to its own value. Our next node is this. Okay. Now priv node.next is next node. And then I want to return next node instead. Right? So what's happening now is that yeah, 5 is here and then it's assigned there. And so 5 is resolved at the fourth call. So 4 is here and 4 is we create a new node based off of 4 and then point 5 to 4 and return 4. Return 4. Okay, so we are returning 1. So we created our linked list, but we are not pointing to it. So what we want to do, we actually want to return this for the final result of the function. So what I can do is to have another helper function here. So I'm going to call this one public static, and it also returns a linked list node, and it's called Palindrome or is Palindrome, and it takes a linked list node as well. And what it does is that it calls recurverse and it passes it the node, and it passes it another thing called head, and we will define head up here. So we will say linked list node head is, or let's call it actually instead of head, reversed head. Right? So reverse head is first initialized to null, and it is passed down there, so it should also receive a linked list node called head, reversed head, and we will call it again and again with that. We won't change its value. And here, what we are going to do before returning this, we are going to call this reversed head, right? And we are going to return that reverse head. What's happening here? Oh, we are not, okay. So that, and here we want to return that reverse head. So we are not changing reverse head anymore. That was the only time. So now if I pass it node 1 and node 1, 2 is a palindrome function, right? And I print it out again. Oh God. Why didn't that work? Reverse head. What was the problem here? Is always null. Why is it always null? It is assigned something here. At the very last iteration, it's assigned something. It shouldn't be always null. if we pass the node here and the reverse head here, and we are returning reverse head, why is it null then? So 5. We're always going to the next node and the next node and the next node until we hit a case where we are assigning the value of reversed head okay. Now reversed head. Why is it always no? I don't get that. Replace with no? No. Why would I replace that with maybe I don't have to pass it like that. Maybe it will be able to detect that. Nope, I need to pass that. And do I need to receive it here? Yeah, I do need to receive it there. What is the cause? I know that is assigned to null. Maybe you want me to assign it a new linked list node? Would that help solve the issue? No. So can I see the value of reversed head here? It's 5 there. Why isn't it 5 here? Why the changes aren't reflected here? So if I... Interesting. It's 5 there. Doesn't it work like that in Java? How would I have a value, have a variable outside then? So let me actually experiment with something easier, right? Let's forget about that and let's create a byte, call it a length, set it to 0, and then pass it here as well, and then pass it here as a variable, and then length plus plus. And then let's console log the length at the end of that. Given type is okay, so length 0 0. Interesting. So how am I supposed to grab the data? So if I pass anything inside this function, it's now... Maybe if I reorder these, if I bring this to the top... No, okay. So I think I have to do a Google search. So that would be how to pass a variable to a yeah, to a function, and oh god, okay, so let me connect to my internet. It's receiving X and Y. So wait a second. So what is the value of length here? Is it being incremented? 1, 2, 3, 4, 5. Oh god. So it was like this. If I remove all the other console logs. Okay. And I want to receive the length after the function is finished. So yeah, that is what I'm seeing. So this is what? This is passed by value. Okay. So what is the other way? Call by reference aliasing. So what is the other way? Okay, so changing the value of class variables. So if I want to do something like that, then I have to create actually fields for my class. So let's do that then. So length is set to 1. And what else? That's not that bad. Reversed reversed head. She's set to no. Or what is it? Byte. It's a linkless note. And I don't need these anymore, and I don't need these anymore as well. And I'm going to say this dot, right? Static. So I don't need to have this as static anymore. Do I need this anymore? Nope. So that's that, and I will also increase the length. Okay, so I'm going to call this with only one parameter, and I'm going to return what is the problem here. Make recruiter static. So make this not static. Okay. And so we have this now. Okay. Good. Now I don't need to do this anymore, and I basically, yeah, I still need this function, okay? So I'm going to call no, do I need this function? I really don't, but yeah, I'm not doing this completely right. On-site method cannot be referenced from a static context. That would be interesting to solve this one. Can I do that? Can I make my main method not static? Class was define public static. So this has to be static. So then, oh god, how am I going to call something that is not static in here? I have to instantiate that, right? I would have to say var reversed is I'm going to call it recurve runner. So new instance of that with node 1 and what's the problem? Okay, so that's for instantiating classes. Oh god. Okay, so well, how can I do this then? Make this static. Make that one static. And then we don't have any references to these. Create field length. Make main.length static. Okay, so that seems to solve the problem. Thank you. Let's run it again. Oh god, we are skipping 4. Okay, so here we are not pointing to anything. And let's point to something actually here. So reverse head dot next should point to a new linked list node with a value of node.data. Is that good now? Okay. Node.data, and then I'm not going to return that. Instead, I'm going to return this one here. I'm going to create this first. Reverse head next. And then I'm going to point to reverse head next. And then I'm going to instead return that one there, but I have reference to the head in my class. 5, 4, 3, 2, 1. Yeah, that was much more effort than I thought it would be. So maybe I don't need that anymore. Maybe I can just say run recurve and then print out the reversed head from our method. Can I do that from our fields? Yeah, so I don't need the runner for that. So this is our reversed head. So that's even cooler. So what is the length of our linked list? If we want to print that now, we are also calculating the length, right? 5. Cool. So 5 divided by 2 would be 2.5. So if we floor that, because we actually don't need the middle element, don't need to check the middle element, so we only need to calculate these two, check these two. So let's rename this back to is palindrome, and now let's call our recurvers on the node inside that, on the node that we are receiving, and then let's default to true, just like we had here. So we are defaulting to true, and let's get to the fun part. So we are creating an if statement because we have the value of length. So if we are going to create a byte of I, initialize it to 0, check to see whether I is less than math. Let's actually calculate this beforehand. Let's call it I don't know, byte limit, or byte half length, I don't know, and it would be length math dot or byte of math dot floor of length divided by 2. Okay, so half length, and if that's that unknown class, I'm not using a class there. If that's that, then I plus plus. And then inside here, why is it unknown class still? Byte expression expected. Oh, sorry, 4. Okay, we're good. So here we are going to say node is, so we are at each iteration, we are going to say node dot data. So at each iteration we are going to check if node dot data is the same as let's rename the reverse head to okay, so node.data is the same as reverse node.data, and if it's not the same as at any given point, it will return false. Okay, what is this? Okay, we are returning boolean. And then at the end, I'm going to say node is node.next, and reverse node is reverse node.next. Okay, so this is what we're doing, and it should work. So I'm not going to call this here. I'm going to say is palindrome. I'm going to call var result, and I'm going to say is palindrome node 1. Okay, and then I'm going to say print the result, and it should work. So it should return false here. Yeah, that's right. So now if I do this, it should return true. Yeah, we solved the problem. So yeah, we had to deal with a lot of Java technicalities, but this is essentially what we're doing. So in order to have a global variable between functions, have a global variable to and have access to that between different function calls, we have to define class fields. So that's what we did here. So we are initializing the length to 1, and we are checking to see whether or we are also initializing another node called reverse node, which is the head. Okay, and it's initialized to null. And here we have our recursive reverse function, and what it does is that it receives the first node of a linked list and then calculates its length while it's recursively calling itself, and it also it calls itself with the next node and stores it in the previous node. And so the next node is becoming the previous node. And when it hits the base case for the very, very last next node, it will automatically assign that to the next node of the head. Okay, so it is in reverse, so it is second to the last node, right? So it would be our F4 in our example, right? F4 is the second to the last node. So this is a node, and this is pointed by the very, very last node, and we are returning the second to the last node, so that it could be the previous node of the third to the last node over here. So on the F3 call over here. So we return 4 so that 3 can point to, or 4 can point to 3. And after doing that, 4 points to 3. And so on this line, we are making that happen. And we are returning the next node, which is 3. So that 3 becomes the previous node for the next node, which will be 2. Okay, and then 3 points to 2, and then 2 points to 1 in the next final resolution of the recursive call, of all recursive calls. And after we construct this, we have a reference to its head inside our class field. And what we do is that we basically call that recurverse function in our isPalindrome function, which returns a boolean, and we are calculating the half length of our linked list using that length field, and we traverse through our linked list for only half its length, and we check the node.data with reverse node.data. So we are reading the data of the nodes once from the beginning and once from the end, and we will stop right in the middle. We won't, or even before the middle node. And if we find any mismatches during our checks, we will return false out of the whole isPalindrome function. And if not, then we will do switch to the next node and continue doing our checks. And if we don't find any mismatch, we will return true. So that's what our function does. And this is our sample linked list. We are calling it, and it returns a boolean, and we are printing out that boolean to the console. I hope it makes sense, and I hope you like this video. Also, please don't forget to subscribe for more coding challenge content, and I will see you in the next video. Bye bye.